Okay, so we are going to look at creating an equation from a line today. We're going to try and find the slope, we're going to try and find the y-intercept, and we're also going to try and decide if this line is showing us proportionate data. All right, so let's remember that the equation for any line is going to take this form, or at least the slope-intercept form is going to look like this: y equals mx plus b. And you might remember that this is our slope, this is our y-intercept, and then of course the y and the x are our two input variables, right? So you might recall that we're going to have a table of data here, right? Let me get my pen back in working order here. We're going to get a table of data, x and y, and these two numbers are going to be related to each other somehow, and oftentimes they're proportionate to each other, these sets of numbers. So let's take a look at some of the numbers that are on this line, and we'll see what we can find. Let's start off by looking at the slope, right? So here we have a slope of x. That point right there has a point of -2 and 1, and the next point I see is right here, and it has a x value of -1 and a y value of 2, and from that I can probably find our slope. Let's put another one up here. It has an x value of 0 and a y value of 3, and we can see that our slope, in other words our change in y, that looks like an x, doesn't it? Our change in y, let me write this again, change in y over our change in x, looks like y is changing by +1, +1, yep, it looks constant. X is changing by -2 to -1, that's also +1, and -1 to 0, that's also +1. It looks like our slope is 1 over 1. In other words, m in this case will equal 1. And we can look at our y-intercept. We remember, of course, that the y-intercept is where the line crosses the y-axis, so I can see that my y-intercept is going to be 3, right? And you might also remember that, well, so let's go ahead and just make our equation here. We can say that y, our output variable, is going to equal 1 times the input variable, 1 times x, plus 3. We can also write that as y equals x plus 3. And let's just see if that's true. Let's take any pair of coordinates from our table and say if x is -2, -2 plus 3 would equal 1. And sure enough, there's our output variable, 1. Let's just try it again. Let's just say y equals, if our input variable is -1, -1 plus 3 should be 2, and lo and behold, there it is. So this equation gives us all of the points in our table. And of course, the points on our table are coming from this line. So this equation maps or graphs this line. Now, if we look at the question of whether these things are proportionate or not, well, we can just look at any two pair. We just say, you could ask yourself, take any pair of numbers. Let's start with negative, we'll put the y on top just for fun, just to be consistent. Our y is 1 and our x was -2. Is that proportionate to 2 over -1? And this obviously has a scale factor of 2, but -2 times 2 does not equal 1. So they're not proportionate. They're not proportionate. And one of the ways that we learn in class to tell if a set of data is proportionate is we can just look and see if it has a y-intercept, right? If b equals anything but 0, these numbers are not going to be proportionate. All right, let's take a look at another one. All right, so let's take a look at this line. I'm just going to do some estimating at first. It looks like that the slope is going to be negative. I know that because if I start here on the left side of the screen and I read over to the right side of the screen, that the line is going down, down, down. So that makes me think that it's going to be a negative slope, right? That's how we can tell something is going to be a negative slope. And I can also see that the y-intercept right here, the line crosses the y-axis at 1, so I can say my y-intercept is going to be 1. Those are my predictions. And I also think that if it has a y-intercept that's not 0, it's going to be not proportionate. Okay, and we can check that later on. All right, let's go ahead and start by picking some lines. And I'm going to choose my lines from left to right. I mean, my coordinate points from left to right. My first one here, let me get a different color to stand out a little bit. My x and y. Okay, my first x looks like it's -1, and my y is 3. My next point here looks like x is 0 and y is 1. And my next point looks like it's all the way down here, a little hard to see. Right, there it is. It looks like x1, y -1. Okay, so x is 1, y is -1. So I'm going to try and calculate my slope. Right? I'm going to think about my change in y over my change in x. And I see that my change in y, it looks like 3 going to 1, that's -2, 1 to -1, that's also -2. My x, 0 to 0, I'm sorry, -1 to 0, that's +1. 0 to 1, that's also +1. So it looks like my change in y is -2 over 1, which simplifies to -2. And that fits my prediction. I expected there to be a negative slope. So given these two pieces of information, let's go ahead and write our equation in slope-intercept form. Y equals -2x plus my y-intercept is 1. Boom, there it is. Now, let's just check and see that it's truly not proportionate. I'm going to pick any two numbers from this set of data. My first ratio was -1 over 3. And let me just rearrange that. Just to be consistent, I'll put the b on top. Okay, so we'll say 3 over -1. And my next set of data was, well, let's pick any set. I'll just show you, it doesn't matter. I'll pick a set down here. The next one, my b was -1, and my y was -1, and my x was +1. And I can see that this is not going to be proportionate, right? I would have to divide this by -3 to make it equal -1. And clearly, if I take -1 and divide by -3, it doesn't equal 1. So this is not a proportion, right? This data is not proportionate, which is what I would expect. All right, let's see if we can zoom through a couple more. Maybe let's try and do it without as much detail. All right, here's another one. All right, again, I see this is going to be negative. Right, and I'm going to try just using the line this time. Let's see if we can just do this with the line. I'm going to try and find my change in y, right? My change in y. And that's going to be the vertical, the up and down change. And I see that between this point right here and this point right here, I'm seeing a change of, see, from -2 to -1. No, I'm sorry. This is my x value here. Right here, my y is 0, right? I'm not at 1, I'm at 0. A change from 0 to -1, right? I'm comparing it to this point right here. 0 to -1, that's a change of -1. This blue doesn't stand out very well, does it? Let me switch to white here. Right, so my change in y went from 0 to -1. That's a change of -1. My change in x, let's find out what that is. x, the x value here is negative 2. The x value over here, right, it goes from negative 2 is my horizontal change to 0. From negative 2 to 0, that's an increase of plus 2. So this slope has, or this line has a slope of negative, right? I have a negative divided by a positive is negative 1/2. Let's see if I can write that a little nicer here. 1/2. I'm not going to simplify it to a decimal. I'm going to leave it as that ratio of two numbers because the two numbers show us two different things, right? The change in y and the change in x, right? The horizontal change over the vertical change. So that's my slope. That's m. I'm going to write that as m. I can also just take a quick look and see that my y-intercept is negative 1, right? So negative 1, right? Negative 1, that's my y-intercept. That also means that it's not proportionate. So here we go. I'm going to say y equals negative 1/2 x plus negative 1. You could write subtract 1 or minus 1, but we shouldn't. Okay, so we've got our negative slope. We see that it's also a more gradual hill. It's not as steep as something with a slope of 1. That's why we see a slope of 1/2. It's a more gentle slope, a smaller slope. All right, let's do one more and we'll be out of here. All right, quick think. Is this positive or negative? All right, if you said it's positive, you are correct. M is going to be positive. Quick, does it have a y-intercept? Yes, it does. If you said yes, it does, you are correct. So let's take a quick look here. I'm going to identify a spot. Oh, here's one way down here. Oh my goodness. All right, what is that? -3, -3. So, and our next point that we can see looks like, whoa, right up here. What is that? 0, +1. So it's a little tough one. Let's just let's figure out what is our change in y. Change in y. That's the vertical change. Again, I'm going to go from right to left. I'm sorry, left to right. We're going to do this like we're reading a book, left to right. I'm going to start with this point, and it looks like we're going from -3 all the way up here to 1. -3 to 1, that's a change of 4. Right? That's a change of 4. And now let's do our change in x. And that's our vertical change. Let's see, we're going from -3 all the way over here to, where is that on the x-axis? That's 0. From -3 to 0, that's a change of 3. Okay, both positive. So it looks like our slope is 4/3. Again, it's not going to simplify to a whole number, so I'm going to leave it as a fraction. And our y-intercept is +1. So that equals 1. So our equation should look like this. Y equals 4/3 x plus 1. And we're going to say it is not proportionate because it has a y-intercept right there. Not proportionate. All right, people, that's it. That's how we can make an equation from a line.